I love following that, don't you? I mean, first of all, half of my talk was handled between this and two earlier talks. So, but that's just going to give me a challenge to make sure that I can teach you something in this next few minutes. But also that I love is the support I'm getting from backups, backup. So my name is Penny Garbus. I'm president of Soaring Eagle Consulting. I have been, and I don't know how to run this thing. I'm sorry. So I have been in IT for over 35 years. I started out as a data entry clerk. I don't know how I did that. So, okay, sorry. Great, okay, thank you. So I started out as a data entry clerk, worked my way up from technical writer, project manager, to now where I'm head of operations at Soaring Eagle. I am not technical. I am a business. I'm used to using IT to solve business problems. And I have a mission. I have a personal mission in that I really want to help companies save their data and their livelihoods. My second mission is I want to put ransomware terrorists out of business and stop giving them a vendor acronym, because right now every time you pay a ransomware terrorist, you are giving them a status of a new vendor in your system. So I like to start out first with a story, but first with a definition of what is HA. High availability is basically where you have a system where you have a production environment that is very well related, very closely related to a secondary environment. It can be multiples. Environment, ready to fail over, ready to share the load, ready to help your business keep the data performing well and accessible and secure. But HA is not the whole story. When it comes to disaster recovery, it's a part of it. And I will share with you a customer that came to us I think it was about a year and a half ago. It's hard. COVID, I do not understand the time anymore. So sometime during COVID, customer came to us, they had just been hacked with a ransomware. And they told us they had decided to pay the ransom. They were also shocked that high availability wasn't enough for them. They had high availability set up and they had backup set up. The problem was they were all on the same network. So once the primary got attacked, all the secondaries attacked, so were all their backups. Everything was encrypted in that network. So they came to us and they said, we paid. They were lucky. They got 80% of their data back, not 100. You rarely get 100. Some people shared stories, and we have heard stories where they got none of their data back. The ransomware terrorists had actually encrypted the data so badly that they couldn't decrypt it. That has happened to a friend of mine in one of my management classes. So anyway, so they came to us and they said, we got to figure out how to line up the rest of this 20% of data. Otherwise, we're losing revenue. Last 6 months of revenue is gone. So we spent the next few weeks helping them line up the data. The next mistake that they made was they decided to roll up and clean in the same environment. They did not go back and do a bare metal, brand new secondary system. They decided to clean where they were, trust the hackers, pay the ransomware, and decrypt there. So they ran for about 3 months, and about 3 months later, their systems were hacked again because those people were not out of their system. However, because they were working with us and because they had realized their mistake about relying on HA and in-place backups, we had them ready to roll up a secondary system, and they were back and full running in a couple of days, and they didn't pay the ransomware again. High availability is used for companies that have a low tolerance for data loss, data slowness, or user interruption. The causes of interruption does not have to be ransomware attacks. The ones that we see mostly are really operating system failures, networking failures, slow disk, hardware disruption, and the other one is bad roll-ups and good people doing, we'll say bad things, but let's say they made a few mistakes along the way. So high availability is a very good part of your disaster recovery because not all disasters are the same. Disasters can be, I think they mentioned it in the security discussion a moment ago, is that, sorry if I'm making this blink, is that disasters can be tiny, they can be slow and easily remediated, and some things can be very large and cause a full roll-up of your system. So I guess I already went through this already, and I call it what causes data interruption rather than just corruption. Because anytime that your users or your clients or your e-commerce sites goes down, you're losing money. Your users are getting angry, people are frustrated, they can't do their jobs, they gotta work late at night. They don't wanna work late at night to finish their work. They wanna get it done and they wanna go home and they wanna go, play with their dog or their kid. So what causes some of these interruptions? You have disk failures, hardware failures, operating system failures, migrating when you shouldn't, installation of bad code. The one thing that we see over and over again is the failure to really roll up properly. Bad Q&A, bad testing, allowing people who roll up allowing people to roll up who shouldn't have permission to do the roll-ups or make changes in the production environment that shouldn't be able to make changes. People who are allowed to write scripts or create reports thinking that it's okay, it's just a little report, it's not going to cause any interruption, and then that report goes crazy and takes up all the memory, CPU cycles, and all of a sudden your users can't have access to, they can't go there and say, hey, I want the newest and latest iPhone off your site because you have it $10 cheaper. You just lost that customer. So those are the many reasons. The other interruption I call is the hero inside actor. This is a person who says, hey, this is my world. I don't want anybody playing here. I'm the only one that knows how to do it. I'm the only one that knows how to fix it. And then they go on vacation. So what happens? All of a sudden, whatever that workload was, can't be done anymore. You're stuck until they get back. So they're great. It is great to have people who really love their job and really want to protect the position and they really care about the business, but do they really care about the business or do they really care about their job? So what you don't want to do, and they mentioned this before too, is any single points of failure. So nobody should be the only person that has access, control, knowledge to do anything inside your system. And the last one is, of course, bad software that you can purchase untested. Every time you buy a software, a new VPN, for instance, in our industry, a new VPN can be very disruptive if it doesn't work well with another VPN. So everything should be tested before you use it and roll it out. What is true disaster preparedness? And they touched about this too. Make sure, first is to have a great defense. Make sure that all access to your systems, physical and through software and through your environment, is all based upon the need to do their job. So you want a roles-based access. And you also want to limit who has access to production. You can have a really great developer who codes really fast, solves business problems really fast, but should that person also be the QA? And should that person also be the person that says this is approved for roll up to production? In most cases, probably no. You want to make sure you have version control all your code. Make sure you can always roll it back and know what you rolled up last week versus yesterday. You also want to have rollback plans. Make sure you can send it back. For DR testing, you want to test Not only the process, but the documentation, and you want to make sure more than one person knows where everything's buried. Where is the documentation? Who knows where the encrypted keys are? Who knows where the application code is? Where's the data? Where's the database? Where are those security MFA instructions? Who needs access to what? Making sure that even though I'm rolling a brand new system, I know who's allowed to access it when it comes back up. Okay, and the last moment is, just like they've been saying all day, backup. Back up outside your production environment, development environment, outside of your network. Air gap it, send it somewhere else. Outside your business building, outside your cloud environment. No environment is free from data loss. If you're in the cloud or if you're on-prem, it doesn't matter. Now I'd like to discuss a little bit about RPO and RTO. When you go back and you talk to your line of business owners and your IT professionals, talk to them about RPO and RTO and what the risk assessment is for each department. You want to know, RPO is the point of, basically it's how much data can you afford to lose. If your system went down right now, can you lose a second, a minute, hours, days, or a month? If it's a month, like somebody said, then you don't need IT staff, so don't worry about it. But you need to know how much data can you afford to lose. That's going to determine what disaster recovery system you want to set up. Next is recovery time objective. That is the amount of time it takes to put on a kill switch and call it and say, this system is dead. And the amount of time it takes to get the system rolled up again. That amount of time is data loss, client loss, sales loss, and user deficiencies and interruptions. So you got to know, well, what is my tolerance for that? There are many paths to data safety, excuse me, but one of the things that we keep saying, and the mantra can't be said enough, I'm sorry, because you would not believe how many times we have seen systems that are not backed up, and then the client comes to us and said, oh, we had something bad happen to us today, can you help us? And we'll say, great, where are your backups? Are they restorable? Have you tested them lately? So backups are essential. No matter which disaster recovery you pick, you have to back up outside that disaster recovery system. An old strategy of disaster recovery was log shipping. In log shipping, you create a full backup, put it in the environment, and then you're sending the data transaction logs consistently to that system. There's a couple problems with that. One is that system is in recovery mode until you got the last transaction log entered that you need. And it may or may not have all your latest application code in it, right? It may not have all your security changes in, right? That system requires a lot of maintenance. And if it's inside the same network, just like HA, anything that happens in the primary system will happen in the log shipping. So if you have a data corruption, it will happen there. Because as you're sending those transaction logs, likely you will not see it. We had a client who said that they had a 1 terabyte system. So they thought they were too large to back up. They backed up 5 years ago. Then they sent transaction logs for 5 years. Then they had a hardware problem which caused corruption in their database. What they didn't realize, that corruption had been going on for a couple months. So they came to us and they said, hey, you help us restore this? And it took us weeks because you would have transaction logs that were good, transaction logs that were bad, and we literally had to manually line up their data as best we could using their technicians and their users. So no system is too large, and no system should be just relying on transaction logs and not doing full backups periodically. Availability groups, that's what we're talking about today, high availability. in availability groups, you have, I'll talk about those here. You have a primary environment like we talked about, and you have a secondary environment. In asynchronous, I'll start with synchronous. In asynchronous, the two systems are BFFs. They are synced. They are always in line. Whatever happens in the primary gets sent to the secondary. The secondary says, oh, I got this, commits it, then tells the primary, I got it, go ahead and commit it. That transaction does not commit it in the primary or production primary environment until the secondary synchronous system says, I got it. I got your back. Here's the proof. That creates the ability to set up automated failovers so that if the primary starts feeling a little weak, slowing down, the secondary can say, I got it, I got this covered, we're gonna let you relax a little bit, and they switch roles. And it does that automatically. For asynchronous, oh, and by the way, you can only have one synchronous secondary on a system. If you have an asynchronous, you can have multiples. And they'll use asynchronous secondary systems to help share data load. You can do all your writes in the production and all your reads in the secondaries. You can share data load as well. And asynchronous, the difference is they're more like barroom buddies. The primary says, hey, this is my data, I'm sending you to, this is all my transactions. And the secondary says, yeah, you can assume I got this. Like, you can assume I'll buy the other round, if I didn't leave my wallet at home. But they're usually a little more, we work better than that, but that's how I remember. Baseline backups are old backup systems. When we talk about backups, do not use simple recovery mode. Simple recovery mode is old. It means that you're only using full backups to protect your data. If you're using full backups, I think I forgot, I missed Rpo and Rto. No, I didn't, okay. If you're using simple recovery mode, your Rpo and Rto is too high. There is no way. Even if you sent a full backup across the pipe and it got restored in the secondary system, by the time you are able to send another full backup, you're gonna lose data in between. Because if there's a corruption sometime in the primary, you don't know when that happens, and you don't know if it made it all the way. So when you're using when you're doing backups, please don't use simple recovery mode. I think we talked enough about log shipping, in that, remember the Rto and Rpo here is high. Also, the only time you really know that that you can put automated alerts on log shipping is if they are in the same network. So there's times when you may not know that your logs actually made it to the secondary system. And we talked about asynchronous already. This is an example of a high availability system where you have one synchronous database and you have multiple asynchronous databases on top of that. They use these a lot in hospitals. For instance, maybe the hospital patient-doctor relationship, all that happens in the production. But hospitals have now a lot of life safety equipment that are run on computers. You might have those spread out over a couple other secondaries, and then you might have audit controls, finance, and all those on another secondary. Replication, I forgot to talk about replication. Replication is the act of, replication is used for systems that are dispersed geographically, usually. For example, you'll have operations in New York, and we talked about that a little bit ago. Somebody asked the question, they will control the truth. everything about the whole corporation, where things at. Let's say they're making cameras in Taiwan or someplace, and they need all the parts, the chips, the communications. Oh gosh, I picked cameras. Oh well, sorry. They will need to order those parts, maybe have them built, maybe have them assembled in Taiwan. But let's say their biggest sales team, let's pretend they're in Hawaii, because the weather's nice there and they have easy access to that part of the world or whatever. And Hawaii wants to know how many cameras they can sell. So they can share that information. So the operations can be talking to Taiwan and say, okay, when are you going to have everything built and ready? Send that information to Hawaii and say to Hawaii, well, this is how many we'll have available to sell. How many are you going to sell? Then Hawaii sends it back to operations, said, this is how many we sold. When can we have the next shipment? So that's when replication is readily used in that kind of example. However, you are copying it table by table. So you can say that operations kind of has some or all their data backed up in Taiwan or between Taiwan and Hawaii. But the problem is, at what point did you lose the data? You are tracking all those objects. So replication is a very good way to share data. It does have a nominal effect of backing it up inside the company, but it does not replace backing up the systems in Hawaii, in Taiwan, and in New York City. You still want to have a disaster recovery plan, and you still want to back them all up. I keep wanting to look there, sorry. What are some common mistakes that people make in their assumptions of DRs? One of them is, believe it or not, like our mantra is backing up. The other is poor training, like they talked about a lot today. They also, poor testing. Poor testing, everything from poor testing of the code you're rolling up, poor testing of the software you might be purchasing, poor testing of your employees and allowing bad access, and then not testing your disaster recovery, not documenting, and not finding all your single modes of failure. So this is just the same thing about there. So I think we covered a lot of, okay, so now I'm going to talk about what's a full DR plan. I'm going to spend a little bit of time skipping some of this because some of this you already know. You already know from the other talks you need to back up. You already know you need to train your employees. You already know from talking with everybody else today that you need to test your employees. What did they learn? Are they following protocols? Are you auditing? When you do your audits, are you reading your audit reports? Are you acting on your audit reports from your security checks and from your employees? And are you doing more retraining? And are you doing things to make sure that at every step of the way, when you run your audit reports, that you're fixing the issues? We have a company that actually audits all of our laptops in our company, and we noticed there was a report missing. The report was, what was the download? Who downloaded what on each of everybody's computers? That report was missing from their report. We're the only customer that reported it missing. So that means that a lot of companies aren't reviewing their security reports that they're paying for every month and making sure that they are fixing things that are broken in their security reports. So you also want to back up not your data, just your data in your database, but your application code. And you want to make sure you know in DevOps, TFS, whatever you're using, that you know which version is the right version. You want to make sure that you have the people that can do the roll-up for the application code. You want to know where are all your security parts. For example, your MFA system, what are you using there? How to reinstantiate it? Where are your encrypted keys for your certificates? for your SSL certificates and other security certificates. That very often when you're doing disaster recovery, those are the things that you realize nobody knows where they are. Or it's always the person who's on vacation who knows where that is and it knows how to get to those keys. You want to test the maybe I said this, but I'm sure if I didn't. You want to test the documentation, and you want to do that during your DR test. And we do a DR test every 6 weeks. There's a couple reasons why. One is people forget. The second reason is that the software changes. Our Azure software environment, GUI changes all the time. And all the other software changes very often. And we actually time our DR failovers to see how fast we can do it, see if we can beat the time from the last time. So we make our own stress at the moment. And the most stressful thing is not finding the right screen or the right button. So it's really silly, but we make sure that every time we go through it, we're looking at those screen captures and we know exactly what we're supposed to do on the screen. Another thing that we found when we did our own DR testing is that you find steps that you miss. Every time you do it, you find a step that you missed, that you didn't realize, because another person's point of view comes into play. And we have an Azure failover. And every time so it's not readily apparent, it's assigned to us when we need it. And that means when we fail over, we need to put our new IP address for our application to run. And we're sitting there, we're trying to figure out, why can't we get this IP address? What's going on? One of our team members went up to GoDaddy. Guess what happened 10 minutes before our failover test? GoDaddy systems went down. So we are half up production, half up in our failover. We had to call it. So we had to call that failover test a failure. In our environment, we don't like to fail anything. So we were all kind of mad that we didn't even think about that. But now we have in there, first step, check with GoDaddy and see how they're doing. You want to make sure you know all your security protocols. You want to know who's in charge, who calls the failover, who calls who says the recovery system is back up and running. I don't let them call it till I can get in. And for some reason, my internet at my house at midnight is slower than everybody else's in the whole planet. So they'll be like, mine's up, I can get in, I'm testing, I can get in, I'm always last. I said, I'm sorry, until I'm in and I know my system's running, I'm not calling this. So you gotta say, okay, who's saying that this system really has recovered? The other thing, just make sure, and I think I mentioned it, but make sure you are, every time we do the disaster recovery test, we always change our team members. We have, for each step of the way, we have at least one other person who knows what to do for the network, for the application code, for the web config, for the database, for the data files, for testing. There's more than one person, and we all take turns who's the lead. That's how we find our single points of failure whenever we do the DR. That has helped us a lot. I think, so in summary, I hope you learned something from my presentation today. Oh, wait, I have one more slide. I almost forgot. Why don't companies do all this? And I think they touched on it a lot earlier. That is money. Believe it or not, some companies in their budgets now have ransomware payments in their budget rather than disaster recovery. They think their systems are too busy, too big, and basically too busy and too big to fail. So they plan on just paying the ransomware. But as I shared with you earlier, and as they pointed out earlier, you don't always get your data back. Sometimes you can't get it back at all. So that's one reason. There's hardware costs, there's software licensing costs, there's getting that data over there, and it has to be an air-gapped system. So you have a full system lying there waiting for their worst day in your business's life. That costs a ton of money, and nobody wants to think about that day. The problem is that day can come, and it doesn't have to be a ransomware attack. It could really literally be a poor roll-up or an inside, we won't call bad actor, but we'll say a human that made a bad mistake. Those happen every day in businesses. So my mantra is disaster recovery isn't just about protecting you from the thieves in the world and the terrorists in the world. Disaster recovery is to protect you from things like weather, right? The fires that we had in California, hurricanes, floods, blizzards, and all kinds of things that can be a disaster in your system. It doesn't have to be ransomware. And if your disaster recovery is, hey, I'll just pay the ransom attack, there's probably 80% of the disasters that you're not covering for if you don't have a full disaster recovery plan. And I just want to point out, since we're talking about HA is good. It's a good strategy to be inside that plan. It helps with a lot of issues that you can have, especially if you cannot tolerate any user inaccessibility or slowness on your system. And the server can crash anytime. You can have operating issues, hardware issues, memory issues. And the other thing that HA gives you is the flexibility to help you transition the workload from your production system to the secondary systems. I hope this helped y'all. I know that a lot of this was touched on earlier, and I hope that you go back and talk to your IT teams and your line of business owners, and gives you some points of thoughts to say, hey, maybe there's some things we need to talk about. Or just ask them, where's the run book? And see what happens. Thank you very much. I want to thank Internet 2.0 and all of you all for staying here in the afternoon. And I'm honored to be on this stage with so many great topics today. But does anybody have any questions?
You mentioned about the disaster recovery. So, what do you think? What should be the affordable time to recover from the disaster recovery? The more the business is down, business is losing money, and of course it depends upon the company size and then amounts of virtual machines you have. But I'm talking about a medium-sized business with 400 employees. So let's say something happened and everything is down. So what do you think? How long it should take? What's the affordable time to bring everything back up and running?
I'm going to ask you a question back.
Yeah, sure, please go ahead.
Okay, do you know where all your data is?
Say again?
Do you know where all your data is? So, do you have a run book?
Yes.
Okay. Do you have a disaster recovery plan?
Yes, we do.
Okay.
Actually two, one on-premises and one cloud.
Okay, great. So, in that sense, you should be able to answer that question yourself through testing. So the best way to answer that question is to test your disaster recovery plan. I can't tell you how long time it'll take you to recover. I don't know the size of your pipe. I don't know the size of your hardware, how fast your disks spin. I don't know the size of your database or data, and I don't know how many applications you're running. So without knowing that, I would not know.
Okay.
Does that help? Is that all right?
It does help, but on top of that, I have another question. And you said, we should do the disaster recovery testing in 6 weeks. Don't you think it's too tight? When we do the disaster recovery testing, it puts a lot of resources. For example, our business is 24/7. And if we are doing disaster recovery testing, we need at least 3 to 4 hours to do the testing to make sure, it's successful or not. And rather than doing in 6 weeks, do you think we should spend time on the good amount of testing, so do once in 3 months or something rather than every 6 months, because we have to stop our production to do the disaster testing?
You know what? You're right. I said something wrong, and thank you for catching me on that. So we don't do a full test every 6 weeks. we don't take production down. We practice rolling up the secondary. About twice a year, we take production down and bring up the secondary, and then the next day, fail it back. So what we do is kind of like faults testing, just to make sure we have all the steps in line. So thank you for catching me on that.
Okay, sorry, one more question, please don't mind. And you did mention about the sync mode and the async mode. I don't know, like, we use always on, for our SQL server, the secondary database backup. Mm-hmm. But for us, as soon as we start using the sync mode, everything gets slowed down. So we are using async mode with every 5 minutes or to recover the data. So what do you think? Why I don't know. It's just as I said, sync mode never worked for us. We are using high availability as well with the different regions.
Yep.
But I don't know what we are doing wrong. But as I said, sync mode never worked.
You caught me again.
It gets the system down.
You caught me on something again. Oh my goodness, I have to buy you a drink or something because you caught me on another thing. So for synchronous mode, it does depend on whether or not that you have a large enough pipe, and it can be disruptive. That's why you would go to asynchronous mode. So you're actually right that is a vulnerability in a, Jeffrey, do I have it right? Oh yeah, I can take that. We can talk together, but you caught me on that. I didn't talk about that, but you're right. There is a vulnerability in synchronous mode, and that I think it can cause some slowness in your machine while you're syncing.
Okay, thank you. Thank you.
Anybody else want to catch me on a mistake?
Question for you right here. So I work in an industry where the privacy of the data is more important than the availability of the data. So at what point does a risk assessment get involved on making a determination on whether you should have what is simply just a warm site where there are systems ready to ingest some data versus fully replicating potentially sensitive data and now having to main two different repositories of a sensitive data set that you might have a strong number of controls around, because that introduces a large amount of administrative overhead, applying this replicating controls, having to have an administrator, testing in both places, that sort of a thing. Can you speak to that a little bit?
Let's see. Everything you're saying is true. So it is hard. It is a pain in the neck to have, and that's why a lot of clients don't do it. I mean, because you do have to protect that data in that second tier, especially when it's outside the environment. You do have to make the security protocols are intact. You have to limit that, and you have to envelop it and protect it just like you do in the primary. And that cost is substantial. And again, you're right, that's one of the problems with having that hidden roll-up thing. But how about this? You get attacked, and that private data just got stolen. What does that cost to your business between your reputation and the fines and the client lawsuits? So you kind of have to balance, right? Some of that to, someday that might happen, but it might not. But then you have to understand that I don't even know what the percentage is now. Our statement used to be, it's not if you get hacked, but when. And so that's when you want to go back, talk to your business leaders, talk to your IT, and say, what is our vulnerability? Do your risk assessment, figure out what that level of cost is for you. Because if it turns out that your insurance company thinks you're negligent, they won't pay. So there's a lot of things, and when we've been through SOC 2 a few times, so if you've been through a SOC 2, they will point out those vulnerabilities to you, and they'll kind of talk, a really good SOC 2 auditor will help talk you through and help you do that risk assessment versus the reality, versus the cost, versus what things you can maybe do to mitigate that you could do in between. Lower some of the costs, mitigate it, and then and still protect yourself so you're not negligent. Does that help you?
It does, thank you.
Okay. Anybody else? Okay. Well, thank you very much. And I really appreciate that y'all listened to me today.